You know, this is what I get for paying absolutely nothing for a phone. And it's now reset to the resolution, so that it's only going to do 10 more minutes. How much time do we have? But, okay, we'll leave it as is. But it'll be an incredibly clear picture of the board. Oh, okay. So anywhere along this line, I'm counting as a success. I do have to slow it down in order to have more accuracy. So we'll go with Dan first. So sort of right there at the board. Yeah, you should feel safe. All right, so as I swing it around, I'm going to release it when it's right here in front of me. All right, so 3, 2, 1, go. And now at 2:30, so it's basically 3 o'clock, so basically somewhere around here. So 3, 2, 1, go. Obviously closer. I think this was a question on the first test also. When you release it, where does it go? Why does it go basically tangent to the path?
Because it wants to keep traveling in the same direction, and the only reason it was going in a circle is because you're putting that like centripetal force on it. So
Okay.
when you release it, it just continues traveling in the same direction it was just going.
That's the direction of acceleration at that point on the circle.
The direction of acceleration, well, we'll get into that. Direction of acceleration is actually towards the center of the circle until I let go. In which case, it becomes a projectile motion problem. So, let's get a little bit more into that. I think I have time, and if not, oh well. So what am I going to do? I have some angle, I'll just label it phi and phi. I'm looking at the object when it's traveling that way and the object when it's traveling that way. I'm going to assume a constant speed. So speed initial is equal to speed final, and this is my velocity initial, and this is my velocity final. What is the formula for speed?
Speed final squared equals speed initial squared.
Going way complicated, I'm looking for just basic definition of speed.
Velocity or acceleration times.
Oh,
Well,
final
you-
minus initial divided by 2.
Meters per second.
I've got it written down.
Speed, not velocity, so therefore
Distance over time.
distance over time, that's all I was looking for. Technically, it's average speed, but speed is constant here, so distance traveled divided by time. Velocity, as Dan said, is displacement divided by time. And I guess the other equation that we'll need is acceleration, is the change in velocity over change in time. So let's concentrate on the third one at the moment. So this is final velocity minus initial velocity divided by time. Well, I have these two vectors pointing in different directions, so I need to somehow get them in terms of the same coordinate system. And so let's just establish a classic I hat, j hat. So I need to break them both up into components. So what is this angle right here?
90 minus 5. The theta looking thing that you called something like 5.
Phi.
Yes.
So y 90 minus phi? This feels right.
That's what I had said. I actually don't know what you're referencing. Is it the like axis down here? Going out to the left?
What is phi?
No. What the angle you're looking for, is it?
This angle right here.
Oh. 90 degrees?
This angle right here. That's 99-degree angle. So let's get some basics here. The velocity is tangent to the path. So this is a 90-degree angle right there. And I keep plastic markers. There we go. That's a 90-degree angle there. I'm asking for this angle right here. Since I have to break the velocity up into I and j components, horizontal and vertical components, I need to figure out what is that angle there. Let's do it step by step. This is horizontal. What is this angle right here?
It's 90 degrees, isn't it?
Yeah, okay, that's 90 degrees, that's a 90-degree angle there. So what is this angle right here?
5 prime.
That's what I would call it.
5 prime.
5 prime, okay. And so what is this angle right here?
Could be 5, could it?
It could be 5, because it is 5. This is one of those few times I actually drew the angles so that you might be able to look at it and go, yeah, those angles actually visually look about the same. I didn't do my classic 45 degrees. Yeah, this is the angle here is 5. So when I break my initial velocity up, it is going to be v, since my speed doesn't change, that's 90 meters, I just write that as v. V cosine theta I hat plus v sine theta j hat. That's my initial velocity. Just broke it up into horizontal and vertical bits. What do you suppose this angle right here is? Or,
Or 5.
yeah, let's go with that one. Do it a little less better on this one, because that's really good English there. That's probably closer to that right there. All right, so this would end up being v cosine theta I hat minus v sine theta j hat. And minus because there's the downward component here over time. If we simplify this top bit here, the I components cancel out. So what I'm left with is this negative v sine j, and there I am putting thetas in there when they should be phi's, and no one stopped me. So I get negative v sine phi j hat minus v sine phi j hat divided by time. And so my acceleration is negative 2v sine phi j hat delta t. This is not the end. This is the middle, and this is the cliffhanger. My gosh, what comes next? We have to somehow deal with time. I do want to point out, even though we're wrapping up here, the direction of the acceleration is vertical, negative. In other words, the acceleration in general over this, the average acceleration over this is down. Ultimately, what we're going to do is we're going to make phi get smaller, so we're going to ultimately find the acceleration at this point right here, and it's pointing towards the center. It's not always down, but it is always towards the center if speed is constant. But that will wait till Monday.
I think it's about to